Hi, this is Aaron Brackman, CSC480. I am a grad student. I am showing you Simacogo right now. So you call Simacogo with the game method and you select difficulty. I'm going to select difficulty of 2 here. I'm going to play a piece of 5 and a piece of 4. And what I'm trying to do is I'm trying to create a box. So you can see it's trying to block me from doing that. You can see it's starting to make moves that prevent me from doing that. The goal of the game there is to try and connect pieces. When you get 4 together in like a box, that is worth 10 points, which is the best, kind of most efficient way to play the game. So anyways, I'm going to explain how the game is run. When you call game, it does this nice while loop where you select a difficulty, it validates the difficulty, then if you've got a good difficulty, it'll run for 80 turns. And then the player is in a while loop to select a valid move. So as long as the player selects a valid move, it keeps going. Otherwise, it keeps asking for a better move. And at 80 turns, it evaluates the game and tells you who's won or who's lost. If I come down here, I designed the game so a board is an object that contains a parent and a child, which is it's a node. So it also contains the state of what the current board is, which is an array of board position objects. I've got the difficulty, which is the ply. I've got the black score and the white score, which is also contained and known within the board. The board position objects contains the index of where it appears on the board, the row that it would appear in, the owner of that position, the score at that position, which basically is checking its neighbors and seeing, hey, are you owned by the same owner as me? And if so, let's update these values here and produce a score, which it just tallies by checking the true values. The board here, you make a move, and the move checks the neighbors. The move updates the scores of the neighbors if they're valid, and they are the same owner, and then it totals up the score, so the score just iterates over all the board positions, and the board positions set the white score or the black score accordingly. And so it does that every time a move is made. And I have a select move here, which just validates the correct moves. I've got a get children function here that just grabs the children within the board, 0 to 9, because there's 9 possible moves. And I've got my evaluate function here. So I've got the min-max algorithm here. Minimax calls, you call minimax with a board, a depth, and a player. The player in this case is always going to be the max player, which is X. We're going to run the moves, and we're going to get the children, so the board and the player. The best move will equal just an arbitrary move. I could have had that being a null value. The best score is then just some incredibly low number, so I chose float negative infinity, so it can evaluate, and you're always going to have a score that's better than negative infinity. So you're going to iterate over the moves, and then you're going to call min play, which recursively will call max play, min play, min play, until it eventually returns the proper score here at the root node. And then you're going to evaluate the score over the other score. You're going to determine which is the best move to make from the root, and then return the best move. And these do the same things, it's just they're returning scores and not moves. Here in alpha beta, I add two more variables. I add the alpha and the beta, which is negative infinity and positive infinity. I'm going to go ahead and get children again, select the best move arbitrarily, go over the moves, and then again recursively call alpha beta min play while decrementing my depth. And when I get to a depth of 0, I evaluate the board on either one of these functions, and then it spits back up and it resets and sets your alpha and it sets your beta. And so as the board moves on, after you get past the first leftmost branch, then you'll have an alpha that gets evaluated and continues on. Finally, that's it. That's the game right there, and that's how it's played. So I hope you enjoyed. Thank you. Bye.